Turn to page 16 of your iPods. You should have already glued down Domain and Range graphic organizer that you received yesterday. If you were absent or left yours in class, Coach Cooper should have a couple of extras. So take a few minutes and copy this down. And I'll explain what it means in just a second. Okay, domain, you'll need to know, are your X values. That's just the generic definition. Your range is your your Y values. Now, when you're dealing with domain and range, you have two different things that you could use. You could use the discrete graph. Now, if y'all will remember that from last week, discrete graphs are ordered pairs on a graph. It could be in mapping, it could be on a table, but those are discrete graphs. Whereas continuous, you had a continuous graph. It could have been a curve, it could have been a line. Any of those things are continuous. Now, the difference in the two is when you have a discrete graph, you're going to list the numbers from high to low. Sorry, from low to high. So that's where those numbers would go for the X values. Whereas discrete for the range would be the Y values. Now notice it has X, semicolon, and then the what we call braces. You guys, I'm not sure what you guys normally call these, but I like to call them squiggles. So you'll hear me say squiggles, so don't freak out on that. And then you have continuous. Continuous has the low number. It's always going to be this sign, X, that sign. So the low number less than X less than the high number. And I know this part's confusing. We'll go over these in more detail during the class time. And then your continuous for your range would be your low number less than Y less than the high number. So again, we'll go over continuous because this does get a little tricky. Now the only thing other than that part is that I want to make sure that you guys know the difference between an open and a closed circle. Now, if you have an open circle somewhere, your sign will be like this. So this will be an open circle, and this will be a closed circle. And you'll literally see an open circle somewhere on there. So you could have a graph that looks like this. You have the parabola with a circle at the top, at the bottom of it. You could have a line that goes like this. Those are open circles. Now, a closed circle sometimes doesn't have an actual circle. Sometimes it'll just be a continuous line. Sometimes it will have the dot, and it will be colored in. So if you have a colored in, it needs a line. If it's open, it doesn't. So that will depend on whether you have a line under there or not. And again, like I said, these can be a little confusing, and we'll go over it a lot more in class. So let's look at the first one. I don't know if y'all noticed, but on this I made sure to highlight the domain in pink and the range in blue. So that's what we're going to do on this. So looking at this first discrete function, and remember discrete is set of ordered pairs somewhere on there. It could be through mapping, it could be through a graph, it could be through a table, ordered pairs in general. This is just 6 points on a graph. Okay, so I'm going to highlight all the Y's in blue, and I'm also going to highlight all the X's in pink. So domain, I'm going to highlight in pink. Range, I'll highlight in blue. So, again, from the top, we have discrete. This is when you list from your low number to your high number. So if you look on here, your low to your high for your x's would be 1, 2, 3, 4, 5, 6. So that's how we're going to label it. We're going to say x. You're going to open your brace or your squiggle, if you will. And you're going to close it. And that's it. Now, because the numbers are so large for your y-axis, what I'm going to do is I'm going to write this a little bit sideways. So I'm going to say y. And this is just so that I can fit all my numbers in there. So 150, 300, 450, 600, and I still didn't have room. 750 and 900, and close it with the squiggle. And that's how you do your domain and range from a discrete graph. Your discrete graph is a lot easier to do than your continuous graph. Although hopefully if we do the the continuous graph enough, then it won't be difficult, because they always ask some kind of continuous graph for domain and range, or at least they have in the past. Okay, so now you have a continuous. Your continuous graph is what's going to give y'all the most trouble, especially that we're just beginning. So what I want you to do, remember we're doing domain in pink. What I want you to do is I want you to do a box from the furthest to the left and furthest to the right. So if you look, I have furthest to the left and furthest to the right. So I've kind of outlined it. Now if you look, what numbers would I have highlighted on the x-axis? Because this is, as you should know, this is your x-axis. So what numbers are highlighted on the x-axis? Well, 0 and 8 would have been highlighted. So we're going to use those two numbers, so 0 and 8. Now if you'll remember from the very beginning when we started this, we're going to start with the low number and then the high number. Now, which of these two numbers is the lowest? Well, y'all should know that 0 is lower than 8. So that means I'm going to start with 0 less than x less than 8. Now, from here, I need to go look to see on here whether it needs a line on the bottom or not. Now, if you do not see an open circle somewhere on there, you have to, it's assumed that it's a closed circle or a colored in circle. So if you look on this graph, there are no open circles. Yes, I technically made one there, but I made it. If you looked and I traced it, there was no open circles. So both of these need lines. And again, don't freak out because this is new. We'll do quite a few examples together in class tomorrow and Friday. So hopefully by Friday you guys will start getting used to seeing this. Okay, so now we're going to look at the range. Now I need to look for the highest point and the lowest point on this graph. Now the common mistake is looking at the y-axis and saying, well, that's the lowest point. But if you look, I got to go to the highest point of the graph. So that would be right here. And I need to go to the lowest point, which would be right here. So I'm going to draw this line. So if you look, what numbers would have been used for the y? Well, the y would have been, if I counted the y-axis right here, it's going by tens. So this would have been 0, because it's touching right here at 0. And then I got to go look at this number. Well, this number would have been 150. So the two numbers that I'm dealing with are 0 and 150. Remember, your lower number goes on the left side, so think lower left. They both start with L. So 0 less than y less than our high number goes on the right. Now, because there's not a circle anywhere on this graph, an open circle, then we need lines underneath. So to clarify everything we've talked about today, your domain and range, your domain are your x values, your range are your y values. So domain x, range y. Remember, if you have a discrete graph, you list the numbers from low to high. For your domain, it's the x. For the range, it's the y, still from low to high. And then when you're dealing with a continuous graph, this is when you have the less than, x, less than, and then your low number goes on your left, your high number goes on the right. So your domain is your x, your range is your y. And remember, you want to box this out. So if you look, the blue is touching the y-axis, the pink is touching the x-axis.